In section 6.4, we continue working with radical expressions, and this is about subtraction and addition, and also more multiplication. When the radical expression is the same, we simply use the distributive property in reverse. So this would be 5 plus 8 times the radical 2, and that's equal to 13 times the radical of 2. In the next expression, we have to watch out for the index. Here the index is 4, here the index is 4 also, so we can combine these two expressions like in the previous example, but this is now has an index of 2, so that cannot be included. So this then becomes 7 plus 3, 4th root of 5x minus the square root of 7. So 7 plus 3 is 10, so it's 10 times the 4th root of 5x minus the square root of 7. In other words, we cannot combine expressions with different indices. In the next example, number 3, it looks like the radicands are different, and they are, but there's something we can do about it, because we can write 45 as a product of 9 and 5. So this then becomes 7 times square root of 9 times square root of 5 minus 2 times the square root of 5. And of course the square root, so 9 times 5 is 45. And now the square root of 9 is 3, so we have 7 times 3, square root of 5, minus 2 times square root of 5. So that is 21, square root of 5, minus 2 times square root of 5. So that is equal to 21 minus 2 square root of 5, or finally 19 times the square root of 5. So that is our answer to this exercise. 19 times the square root of 5. To combine the terms in the next exercise, we have to be a little bit creative here. And so we write the first term as 3 third root of y to the third times y squared. And we leave the second term the way it is, 4 third root of y squared. And the last term, we realize we can write as the radicand. We can rewrite the radicand as 2y squared to the third power. Y squared to the third power is y to the 6th, and 2 to the third power is 8. So then the first term, we can, the third root of y to the third is y, so we have 3y times the third root of y squared, and we have 4 times the third root of y squared, and the third root of 2y squared to the third power is 2y squared. So now we can combine the first two terms, and that then becomes 3y plus 4, 3y plus 4 times the third root of y squared plus 2y squared. So that's the answer to this exercise. 3y plus 4 parentheses times the third root of y squared plus 2y squared. The next exercise is a guided solution problem. So here, from the radicand in the first expression, we know we can factor out at 25. So it's 25 square root of 25 times x minus 1. And in the second radicand, we can factor out a 9. So then the square root of 25 is 5 times the square root of x minus 1. And the square root of 9 is 3. So minus 3, that's where the minus sign comes from. And then 5 minus 3 is equal to 2 times square root of x minus 1. That would be the final answer then. I would encourage you to do some extra exercises that pertain to this particular section 6.4. There are lots of them in the book. So if you feel you need some more exercise, have at it. Now we're going to talk a little bit more about multiplication. And so here we're assuming that the radicands were formed by raising, that no radicands were formed by raising negative numbers to even powers. So that's a no-no. So the way we proceed here, we simply apply the distributive property. So we multiply the square root of 2 times 5 radical 2. So that becomes then 5 times the square root of 2, square root of 3. That would be the first step. And then square root of 2 times 3, square root of 7. So 3 times square root of 2, square root of 7. Or 5 times square root of 2, square root of 3 is equal to square root of 6. And then 3 plus 3 times square root of 2 times square root of 7 is the square root of 14. And that would be the answer to this exercise. 5 times square root of 6 plus 3 times square root of 14. And the next exercise is quite similar to the one we just did. Again, we use the distributive property. So the third root of a squared times the third root of 3a is going to be the third root of a squared times 3a minus the third root of a squared times the third root of 2. So there would be the third root of a squared, or 2 times a squared. So then the first expression, we can multiply the a squared times the a, so we get the third root of 3a to the third minus the third root of 2a squared. So the third root of a to the third is equal to a. So we have a times the third root of 3 minus the third root of 2a squared. So that's the answer to the next question here. So a times the third root of 3 minus the third root of 2a squared. For the next exercise, we simply apply the rules we learned about multiplying polynomials. And so you can look at the radical expressions as variables in a way. but it's the same idea. We multiply radical 3 times 2 times radical 3. So that's 2 times radical 3, and then radical 3 times radical 2. So it's radical 3 times radical 2. And then we have minus 5 times radical 2 times 2 times radical 3. And then we have 5 times minus 5 times radical 2 times radical 2. So radical 3 times radical 3 is radical 3 squared, or 2 times 3. And then we have radical 6 plus radical 6. 3 times 2 is 6. And again we have minus 5 times 2 is minus 10. Radical 2 times radical 3 is radical 6. And then minus 5 times radical 2, or radical 2 squared is 2. So minus 5 times 2 is minus 10. When we combine like terms, 2 times 3 is 6. Minus 10 is minus 4. And 1 times radical 6 minus 10 times radical 6 is minus 9 times radical 6. So that is then the final answer to this exercise here. So minus 4 minus 9 times radical 6. So a lot of details, and but you get used to that. So for number 9, we multiply square root of a times 3 times square root of b. So we get 3 times square root of ab. And then square root of a times minus 4 times square root of 3 would be minus 4 times square root of 3a. And then we have 2 times 3 is 6. 6 times square root of 3b. Square root of 3 times square root of b is 3b. And then we have square root of 2 times square root of 3 minus 8 times minus 4 times square root of 3. So it's minus 8 times square root of 3 times square root of 3. So we cannot really combine any of these terms. So we get 3 times square root of ab minus 4 times the square root of 3a plus 6 times the square root of 3b. However, the last term, we know that square root of 3 times square root of 3 is square root of 3 squared, or 3, and 8 times 3 is 24 with a minus. So that would be our answer to question number 9. So 3 times the square root of ab minus 4 times the square root of 3a plus 6 times the square root of 3b minus 24. And number 10 is another guided solution problem. Again, we recognize that these are of the form a plus b times a minus b. It would be a squared minus b squared. So there would be square root of 2 squared, minus square root of 5 squared. And of course the square root of 2 squared is 2. And square root of 5 squared is 5, so 2 minus 5, or the answer is negative 3. In a way, it's an amazing product when you think about that. You start out with irrational numbers like square root of 2 and square root of 5, and you wind up with a rational number. But that's the way this works. Similarly, for number 11, it's the same approach. It's a minus b times a plus b. So that would be equal to square root of p squared minus the square root of q squared, and that's equal to p minus q. Number 12 is really, we can write as 2 times the square root of 5 minus y times 2 times the square root of 5 minus y. And so it would be 2 square root of 5 squared minus 2 times square root of 5 times y, and then minus y squared, plus y squared. And 2 times square root of 5 squared would be 5 times 4, or 20, minus 2y square root of 5 plus y squared. So the answer to number 12 is then 20 minus 4y square root of 5 plus y squared. And the next exercise is basically the same, and we can either use the a plus b parentheses squared as a squared plus 2ab plus b squared approach. We can just do that as a shortcut. So it would be, our a squared would be 3 square root of 6 squared plus 2 times 3 square root of 6 times 2 plus b squared, so b squared would be 2 squared. So 3 times the square root of 6 squared would be 9 times 6. 3 times 3 is 9, and square root of 6 squared is 6. And then here we have 2 times 2 is 4, times 3 is 12, times square root of 6. And then 2 squared, of course, is 4. So that is equal to 9 times 6 is 54, plus 4 is 58, plus 12 times square root of 6. So that is the answer to number 13. 58 plus 12 times square root of 6. And this concludes section 6.4, and I would just encourage you to do additional exercises from the section in the book, section 6.4. Section 6.5 is more on division of radical expressions, and there are two objectives. Number one, to rationalize the denominator of a radical expression, having one term in the denominator, and then rationalizing the denominator of a radical expression having two terms in the denominator. So we begin with having one term in the denominator. And so here's the definition and the procedure of rationalizing denominators. And so it's quite useful in mathematics to find an equivalent expression without a radical in the denominator. This provides a standard notation for expressing results. And the procedure for finding such an expression is called rationalizing the denominator. And so we begin by rewriting the expression, the root of a quotient as a quotient of roots. So it would be the square root of 2 divided by the square root of 5. And the square root of 5 is an irrational number. And so we want to have a rational number. That's why it's called rationalizing the denominator. So if we can make the denominator a perfect square of 5, then we have achieved our goal. So we multiply the denominator by the square root of 5. So we have a square root of 5 squared. And of course, we need to multiply the numerator by the square root of 5 also. So in the numerator, we have square root of 5 times square root of 2, or square root of 10. And in the denominator, we have the square root of 5 squared. And that, of course, is equal to 5. So now we've rationalized the denominator. The denominator now is a rational number, 5. In a similar way, we proceed when we have like a third root. Again, we begin by rewriting the expression as a quotient of roots. Third root of 5 divided by third root of 4. Third root of 4. And now the objective is to make the denominator a perfect cube. By multiplying the denominator by 2, the square root of cube root of 2, of course also in the numerator, third root of 2, then in the numerator we get the third root of 10, 5 times 2 is 10. In the denominator we get the third root of 8, or the third root of 2 to the third. And that would be equal to 2. Third root of 10 divided by 2. So here we've rationalized the denominator, so it would be equal to the third root of 10 divided by 2. In the guided solution, we are looking at the example of the square root of 4a divided by 3b. So we write the expression as a quotient of roots, the square root of 4a divided by the square root of 3b. And to rationalize the denominator, we multiply the denominator and the numerator by the square root of 3b. So then the numerator, we have 4 times 3 is 12ab. And in the denominator, we have 3 squared times b squared. And so we can write 12 as 2 squared times 3. And the square root of 2 squared is 2. And then in the denominator, we have the square root of 3b quantity squared, or 3b. To rationalize the denominator for number 4, we have to come up with a perfect fourth power expression. So we can do that by multiplying the numerator and denominator by the fourth root of 2 to the third, or 8. So fourth root of 2 to the third, or 8. So in the denominator, then we have the fourth root of 2 to the fourth. 2 to the third times 2 to the first power is 2 to the fourth power. And in the numerator, we have the fourth root of 7 times 8 is 56. And of course, the fourth root of 2 to the fourth power is 2. So we have rationalized the denominator. And in the numerator, we have the fourth root of 56. So that's equal to the fourth root of 56 divided by 2. That's for number 4. Number 5, we begin by rewriting the expression as a quotient of radicals. So it would be the third root of 3x to the fifth divided by the third root of 2y. So for the denominator, to rationalize the denominator, we need to multiply the radicand by 2y to the second power. And of course, that would be also then for the numerator, 2y to the second power. So then in the denominator, we get 2y, the third root of 2y to the third power. And in the numerator, we have 3, then x to the fifth would be x to the third times x squared. And the third root of x to the third is x. So then we have 3x times 2y squared would be 12x squared y squared. And so then the denominator rationalizes to 2y, and in the numerator we have x times 12x squared y squared. So it's x square root of 12x squared y squared, third root, divided by 2y. So now the solution is complete, now that we have all third roots everywhere. To rationalize the denominator in the next exercise, let's focus on the denominator, and the numerator will take care of itself. The numerator is simply 7x. Now for the denominator, we notice it's a y to the fifth, so it can be written as y to the third times y squared. And so the third root of y to the third would be y. So that leaves us the third root of 4xy squared. So now we need to multiply this by another third root. So we get a perfect cube in the denominator. So 2 times 4 is 8. That would be perfect cube. So 2. And then to get an x to the third, we need an x squared. And to get a y to the third, we need a y. And of course, that'll be the same expression in the numerator. Third root of 2x squared y. So what we have in the denominator now is y times, and then we have the third root of 2x y to the third power. 2 times 4 is 8, so 2 to the third is 8. X squared times x is x to the third, and x raised to the third power is x to the third. And y squared times y is y to the third, so we get the y to the third here from raising y to the third power. And so in the numerator we have 7x times the same expression, third root of 2x squared y. And next step would be to write it as 7x times the third root of 2x squared y divided by y times 2xy. 2xy to the third root of that would be 2xy. And now we can cancel the x's in the numerator and denominator. So then our final answer would be 7 square root of, cube root rather, of 2x squared y divided by 2y squared. So that's the answer. 7 times the cube root of 2x squared y divided by 2y squared. To rationalize the denominator when there are two terms, we introduce the idea of conjugates. So certain pairs of expressions containing square roots, such as c minus the square root of b, c plus the square root of b, square root of a minus square root of b, or square root of a plus square root of b, are called conjugates. The product of such a pair of conjugates has no radicals. And so we're going to look at that here in a moment. So here is the c minus square root of b times c plus the square root of b. Again, that follows the pattern of a minus b times a plus b, which is a squared minus b squared. So that's equal then to c squared minus square root of b squared. So it's equal to c squared minus b. Normal radicals. So one is a conjugate of the other. And the next example is the same way. Square root of a plus square root of b times square root of a minus square root of b. That's equal to the square root of a squared minus the square root of b squared, which is a minus b. For the guided solution, we have the expression 14 divided by 3 plus the square root of 2. So the conjugate of 3 plus the square root of 2 is 3 minus the square root of 2. So 3 minus the square root of 2. So we have 14 times 3 minus square root of 2 in the numerator. And we have 3 plus square root of 2 times 3 minus square root of 2. And so that will be a plus b times a minus b. So a squared, 3 squared, which is 9, minus square root of 2 squared, and the square root of 2 squared is 2. So that means we have 14 times 3 minus square root of 2 divided by 7. 9 minus 2 is 7. And now we can cancel the 7 against the 14 to give us a 2. And now using the distributive property, 2 times 3 is 6. And then 2 times minus square root of 2 is minus 2 times square root of 2. And that would be the final answer. For number 12, we multiply numerator and denominator by the conjugate of 1 minus square root of 2, which is equal to 1 plus the square root of 2. So we have 1 minus square root of 2 times 1 plus square root of 2. And so the numerator we already have is 5 plus the square root of 2. So 5 plus square root of 2. And then we multiply by 1 plus square root of 2. So that gives us 5 times 1 is 5. And 5 times square root of 2 is 5 times square root of 2. And square root of 2 times 1 is square root of 2. And then square root of 2 times square root of 2 is 2. In the denominator, we have 1 squared minus square root of 2 squared would be 1 minus 2. And now collecting like terms in the numerator, we have 5 plus 2 is 7. And 5 square root of 2 plus 1 square root of 2 is 6 square root of 2. And in the denominator, 1 minus 2 is minus 1. So then the final answer is minus 7 minus 6 times square root of 2. So that's equal to minus 1 minus 7 rather, minus 7 minus 6 times square root of 2. So this concludes section 6.5. And again, I would encourage you to do additional drill exercises in section 6.5 in the book.